Okay, it should be clear that, just as an example, the absolute value of x equals 5 has two solutions. There are two values of x that make this true. When x is 5, the absolute value is 5. When x is negative 5, the absolute value of x is 5. So, let's solve the equation absolute value of x minus 3 equals 7. Well, if the absolute value of something equals 7, that something has to either be 7 or negative 7. So if x minus 3 is 7, then its absolute value is 7. So x minus 3 equals 7 gives you a solution to the equation. But if x minus 3 is negative 7, its absolute value is still 7. So x minus 3 equals negative 7 gives you a solution to the equation. Solving, we get x equals 10 or x equals negative 4. So, an absolute value equality typically splits into two equalities. One where whatever's inside the absolute value is equal to the positive number on the other side, and the other where it's equal to the negative of that number. Okay, so what do we get now? If we have the equation x squared plus x, absolute value of x squared plus x equals 6. Well, one solution, or one possibility is that x squared plus x is equal to 6. So x squared plus x could be equal to 6. Another possibility would be that x squared plus x is equal to negative 6. Now, x squared plus x equals 6, we recognize this, I hope by now, as a quadratic, is going to then be x squared plus x minus 6 equals 0, which factors into x plus 3x minus 2 equals 0, giving us solutions x equals negative 3 or x equals 2. Alternatively, we could get x squared plus x equals negative 6, giving us x squared plus x plus 6 equals 0. Now, in this case, there's no real solution to this equation, although for solving over complex numbers, we would get a complex solution. That won't always be the case. If we had absolute value of x squared plus x equal to, let's say, 1/5, okay, if this is, instead of 6 was 1/5, then we'd have x squared plus x equals negative 1/5, putting it into this form, and testing the discriminant, we would find that we would get two solutions here. So it's possible, if you have a quadratic here, again, x squared plus x is a quadratic expression. Inside your absolute value signs, you break into two equations, and each equation will typically give you two solutions. Okay, this equation gives you 2, this equation will give you 2. In this particular case, the 6 was too big for the x squared plus x, and we got no real solution. Had it been x squared plus 5x equals 6, then we would have been able to get a solution here. And over here, we would have been able to get a solution, but would have been one we could have factored. Anyhow, it's possible then for an equation like this to get 4 real solutions. Now, I went on a little about this. Let's just look at a specific example. And I actually thought we were going to have to use a quadratic formula for one of these because I wasn't thinking. Absolute value x squared plus 5x equals 6 breaks into x squared plus 5x equals 6, and x squared plus 5x equals negative 6. Either way, if x squared plus 5x is either 6 or negative 6, its absolute value is 6. So x squared plus 5x plus 6 rearranges into x squared plus 5x minus 6 equals 0, which can be factored. X plus 6 times x minus 1 equals 0. Over here, x squared plus 5x equals negative 6 rearranges to x squared plus 5x plus 6 equals 0. Can be factored to x plus 2 times x plus 3 equals 0. So that, okay, over here, this factoring tells us that x could be negative 6 or 1. Either negative 6 or 1 will make x squared plus 5x equal to just plain old plus 6. Factoring over here, we quickly see that x is negative 2 or x is negative 3. Either negative 2 or negative 3 will make this thing inside the absolute value equal to negative 6, so its absolute value will be 6. So the solution set to this equation consists of the elements negative 6, negative 3, negative 2, and 1.